Hello everyone, welcome to this next video on complex analysis. In this video we shall take up question from GATE 2005 consisting of 2 marks. The question says the number of zeros of this equation, we are given this equation z raised to power 5 minus 12 z square plus 14 is equal to 0 that lie in this particular region is which among these 4. So out of these 4, what is the number of zeros or roots of this particular equation? So let us first see what is this region. So we have all those z, all those complex numbers which lie in this particular annulus. So let us have a look what is this region. So here we have these two quantities. So one is this thing, that means z is greater than equal to z. So for that, firstly we'll mod z is greater than equal to 2. So for that we just take the equality constraint and let us first draw the circle centered at 0, radius 2. So say this is 2, right? So this particular circle would be this one, and for this inequality they are saying mod z strictly less than 5 by 2. We'll first write this equality mod z is equal to 5 by 2. 5 by 2 is 2.5, so it would be somewhere here, right? So let us draw the circle over here. So now they are saying our region is in between these two circles. So our region is this one, this ring region which is called annulus, and this boundary, that means this boundary having radius 2, that is being included in our region. So they are saying in this particular region find the number of zeros of this equation. So for that we'll make use of Rausch theorem again, where they are saying if you have two polynomials which are analytic inside and on a simple closed curve C, then moreover, if this inequality is being satisfied, then the number of zeros in f of z plus gz and f of z, they are the same. So for that, let us first see what are the number of zeros when we consider the region, when we consider the circle C1 to be mod z is equal to 2. So basically what we are doing, we are firstly seeing what are the number of zeros here inside this region. Say this is our C1, right? And let us call this circle to be C2. So thereafter we shall see what are the number of zeros in this circle C2 where mod z is equal to 5 by 2. So in order to obtain the number of zeros lying in this particular annulus, we just subtract the number of zeros of C2 minus the number of zeros which are present in C1. So that would give you the number of zeros present in this annulus region. So for this, firstly we'll assume f of z to be z raised to power 5. Now this is your choice. You can choose f of z and g of z accordingly, and you can just try what are the number of roots you obtain in your case. So in my case I am assuming f of z to be z raised to power 5 and g of z to be this one, so that when you add these two you obtain this particular equation again, this particular polynomial again. So if I evaluate this particular thing, the modulus of f of z divided by g of z, so that would come out to be this thing is less than equal to the value of f of z, that would be z mod z raised to power 5, and the value of g of z, so that would be minus 12 mod z square plus 14. And when you solve this, when you substitute z is equal to 2 here, so that means in effect you are doing 2 to the power 5 minus 12 into 2 to the power 5 plus 14. What will you get? You would have 32 divided by 62. So that is less than 1. Therefore in this case we obtain mod of f of z strictly less than mod of g of z. Therefore what was g of z? G of z was this polynomial. So accordingly f of z plus g of z by Rausch's theorem, this would have the same numbers of zeros as that of g of z, and g of z has power 2. So that means this have two roots lying inside C1. So we got the number of roots that lie inside C1. So now let us check what are the number of roots that lie inside C2. For that, we again assume f of z to be z to the power 5 and g of z to be minus z square plus 14. Right? So when you calculate f of z divided by g of z modulus, and when you substitute their values, so you'll be having, so when you solve this thing, so you would have 3125 divided by 2848. How did you get this thing? When you substitute z is equal mod z is equal to 5 by 2 in this particular expression. So now this quantity is obviously greater than 1. So now if this is greater than 1, that means you can say the modulus of f of z is greater than g of z. So again, by Rausch's theorem, the expression f of z plus g of z, that would have the same number of zeros as that of this polynomial. And what is the order of this polynomial? 5. So that means this particular polynomial also has 5 roots that lie inside C2. So all in all, if we have in C2 5 roots and in C1 2 roots, so in effect we would have 5 minus 3. That means 5 minus 2, 5 minus 2, that means 3 roots in the annulus region, which is given to us in the question. So our answer here is option number B. So that is it for this video. Thank you for watching.